Hey guys, Miss Moxley here with your recording for today. So what I've got on the screen here is I've got the agenda, and you guys of course can find this in the announcements. You've got your recording for today, which is the acceleration lesson and quiz, and we're going to take a look at the acceleration assignment that's in the acceleration lesson. This week you'll have an assignment with each lesson that's embedded in the lesson. I want you to do those assignments for practice. Then if you have questions or if you need help, of course, we'll go over them, and we'll go over the others on Wednesday when we meet for our live session. But just know the assignments, the practice that are in the lessons, I do want you to do those. Just make sure that you have them in your notes and we will go over them. You do not have to do the labs or the activities that are in the lessons. The ones that require materials, things of that nature, you don't have to do those. So acceleration lesson and quiz for today. Then tomorrow, Newton's second law of motion lesson and quiz. Again, make sure you're doing that written assignment, the practice that's in there. Wednesday, work lesson and quiz. Thursday, power lesson and quiz. Friday, Newton's third law of motion lesson and quiz. Again, each lesson has a practice in the lesson, so make sure that you're doing that practice. Make sure it's in your notes. Mr. Wilson will check for your notes this week on Friday for your notebook check, and he will send that to me. All right, so acceleration. Let's talk about acceleration. So what I've got pulled up is basically the acceleration assignment that you'll find in the lesson. I've just got it pulled over on a different page. It's in the teacher view, so it looks a little bit different from what you guys might see. But we're talking about acceleration. So acceleration is constant change of speed, the constant change of speed. Whether it's increasing or decreasing, that constant change of speed is considered acceleration. It's also considered a change in direction. So any object that is in motion that has a change in direction, this is also considered acceleration. So with these two statements in mind, constant change of speed and the change in direction of an object in motion, what we're talking about is a change in velocity. Velocity is the change of speed or the change of direction. So we're talking about a change in velocity when we're talking about acceleration. If you look at the two equations that I have here, the acceleration equation and the velocity equation, it says acceleration equals change in velocity divided by time. And then you look at the velocity equation, and velocity equals displacement divided by time. So what displacement is the change in time or the change in direction. So with our two problems that we're going to be working here, what we're talking about is a change in time, a change in speed. So looking here at number one, let's look at this together. We'll work through them together. Now this week, when you're going through your lessons and you're doing those practice items in the lessons, what you're going to have to do is you're going to have to toggle back and forth in the lesson between the examples in the lesson and the practice problems, okay? So make sure when you're looking at and you're going over the examples in the lesson that you understand those and use those examples in the lesson to help guide you through the practice, okay? They'll basically be the same setup, just different numbers from the examples to the practice. All right, so looking at number one, you are standing next to your friend ready to race across a 100-meter field. When the go signal is given, you take 5 seconds to get to your maximum sprinting speed of 12 miles per hour. That's about 5.4 meters per second. What is your acceleration in meters per second squared, okay? Our answer when we're talking about acceleration is always going to be meters per second squared. That's just how the answer is going to be written. Your change in velocity is going to be written as meters per second. So with this first equation, how we need to set this up is we need to take this acceleration equals change in velocity divided by time. We're going to use that equation to determine our answer. So what we've got is our final velocity minus our starting velocity divided by time. And let me toggle over to the whiteboard here. So we've got our final minus our starting divided by time. Okay. So we've got our final time minus our starting time divided by the change in time. So our final speed from equation 1. Let me toggle back over. Oops. Our final speed says we have 5.4 meters per second squared, or meters per second. 5.4 meters per second. And our starting speed was 0 because we were standing still. So what we're going to have is our final of 5.4 meters per second minus 0 meters per second divided by, and I know that you guys are probably wondering why I'm using the backslash. When you get to geometry, the backslash is used for division, just as it is the division symbol. But I don't have a division symbol on my keyboard. I have a backslash, so we're using the backslash. So understand that that is also considered a division symbol. Just don't want to confuse you guys if you're not aware of what that is. And 5 seconds was how long it took us to have this change in time. So you should subtract first. And this would actually be in parentheses. All right, so 5.4 minus 0. And if you're looking at your calculator, 5.4 minus 0 is going to give you 5.4 seconds. Okay, so let's come down and let's just do 5.4 meters per second divided by 5 seconds. So all I've done is reduce the equation just to kind of condense it and clear it up for you guys. 5.4 meters per second divided by 5 seconds, if you've got your handy calculator out, gives you what? That would be 1.08 meters per second squared. And now, of course, your squared should be tiny and as an exponent, so it should be in the upper right-hand corner. I don't have the power to do that here on our screen, so it would look something like that. Just make sure you write it as your exponent. So 1.08 meters per second squared would be your final answer there. So in terms of our change in speed here, we have an increase in velocity. So when we have an increase in velocity, we have a positive acceleration. Moving to the next question, number 2, after you cross the finish line, you slow down and come to a stop, breathing hard. It takes you 10 seconds to come to a stop. What is your acceleration? So let's look at this one, number 2. All right, and we're going to use that same equation for acceleration. Final minus starting, so our change in velocity, final minus starting divided by time. All right, so our final from equation 1 is 5.4 meters per second. And with 5.4 meters per second, actually 0 being our meters per second, I apologize, because 0 was our final speed, because we slowed down, so we've slowed down to 0. 0 minus 5.4 meters per second, because that was our starting, so final 0, starting 5.4. 0 minus 5.4, if you put that into your calculator, you'll notice that that gives you a negative number, okay? And per our equation from number 2, we're going to divide by 10. Let me put some parentheses there so I'm not confusing you guys. Whoops. Sorry. All right, so it gives us a negative number. So it was negative 5.4 meters per second. And we're going to divide that by 10 seconds, because it said it took us 10 seconds to slow down. So when you divide 5.4 divided by 10, that gives you a negative 0.54 meters per second squared. Okay, so your second answer should be a negative 0.54 meters per second squared. Now this is negative, so we have a negative or a decreased velocity. This gives us a negative acceleration, so we have a deceleration. All right, a decrease in velocity would be negative acceleration, which is considered deceleration. So you guys could say deceleration for this one, which is a negative acceleration. All right, and this one, number 1, was a positive acceleration. All right, so again for this week, just make sure you're toggling back and forth between the examples and the practice problems. If you have questions, we'll go over them Wednesday. I'll try to make some recordings between now and then for you guys and those individual assignments as best as I can and as time allows. But again, we'll do our best to make up for it on Wednesday. If I don't get a chance to make those individual recordings for you, we'll make them up on Wednesday and we'll see about all of those questions. All right, guys, so have a great rest of your day. Make sure you're taking those written notes. Make sure that you're doing those practice problems. And I will talk with you guys on Wednesday. Bye. Have a great day.